Okay, hey guys, this is our second video, series and sequences questions. So if you didn't review the first video, which was series and sequences theory, please review that one before you watch this video, because all of the concepts discussed in that video are going to be on this one. So let's get started right into this. So we want to find the sum from r is equal to 1 to 20. Now, remember we said that whenever we're using the rules that we outlined, that we have to be starting from r is equal to 1. Otherwise, we can't use the equations that we had from before. Okay? So we have to always watch our lower boundary and make sure it starts at r is equal to 1, right? So, using the rules from before, we said that if you have, using this now we could break this up. This is equal to 2 times the sum from r is equal to 1 to 20 of r squared. Recall that rule, right? One of these summation laws, plus the sum from r is equal to 1 to 20 of 5. Okay, and if you recall now, if you want to find the sum from r is equal to 1 to a number n of r squared, the formula is n into n plus 1 into 2n plus 1 all over 6. Okay, so using that equation we'll have 2 times 20 into 20 plus 1 times 2 times 20, which is 40, plus 1 all over 6. Okay, and then plus, we know if we want to find, so this here is 5 is a constant, and we have another rule for constants. If we want to find the sum from r is equal to 1 to n of a constant c, this is equal to n times c, if you recall from the first video. So this here is equal to plus 20 times 5. This here would just be equal to 20 times 21 times 41 all over 3. Because if we cross this out here, we get 3 here. Plus 100, because 20 times 5 is 100. And using my calculator, we will get 5,848 as our answer for this question. So again, all it simply involves is using the rules we mentioned before and applying it to the different situations, okay? So our next question, keeping it simple, is the sum from r is equal to 1 to 50 of r multiplied by r plus 1. Now remember again, we look at the lower boundary, it's r is equal to 1, so we could use the equations we mentioned before. Okay, simple. Now note for this one, this here is not, we cannot find the sum from r is equal to 1 to 50 of r and multiply that by the sum from r is equal to 1 to 50 times r plus 1. It does not work like that. Okay, we cannot do it this way. So what we have to do is actually expand this out, because this is wrong. Okay, so we find the sum from r is equal to 1 to 50 of r squared plus r. Okay, again using the rules from before, we have the sum from r is equal to 1 to 50 of r squared plus the sum from r is equal to 1 to 50 of r. Okay, and again using the rules from before, we know that the sum from r is equal to 1 to n of r is equal to n multiplied by n plus 1 all over 2. Okay, and again for this one, r squared, we have this formula above, which is n into n plus 1 into 2n plus 1 all over 6. So this would therefore be equal to 50 into 50 plus 1 multiplied by 2 times 50 plus 1, which is equal to 100 plus 1 all over 6 plus 50 multiplied by 50 plus 1, which is 50 plus 1 all over 2. Okay, and to get our answer, all we simply have to do is add this up. Okay, 6, and this is equal to 44,200. So I was just doing it on my calculator here to make sure. Okay, so again, what this rule showed us, so the first example was a basic example of how to use the laws. This example showed us that we cannot multiply if we have terms being multiplied, unless the only way we could have used this is if this was a constant. Okay, now our next question now, it's a little bit more tricky, because notice our lower boundary, we start at r is equal to 20. Okay, remember we said to use the rules we have to start at r is equal to 1. Okay, so this one here is also fairly simple, except we have an additional step, right? So again, using this, we're going to find the sum from r is equal to 1, from r is equal to 1 to 100 of r cubed. So we pretend like if we're starting from 1 plus the sum from r is equal to 1 to 100 of 3. Okay, but this, since we added from 1 to 100, we just really want to find from 20 to 100. So this value here, what we calculate here, will actually be bigger than what we calculated. So this will be equal to this minus the sum from r is equal to 1 to what? To 19. Okay, so all it basically saying, like, is let's say we want to add 1, 2, 3, 4, 5, right? And let me say we just want to find this. All we're doing is finding this and subtracting this. Okay, and that will give us this. That's the logic we use in here. So notice when we find what we minus it is from r is equal to 1 to 19, because we still want to include the 20th term in our sum. Right? Again, if again I want to find the sum of from, let me say for this example I highlighted here, the sum from r is equal to 3 to r is equal to 5. I need to go one, start minus from 1 below, right? So I'm going to minus the 1 and the 2. In the same sense, we're going to go from r is equal to 1 to 19, and we're minusing that. Okay, so we're minusing from r is equal to 1 to 19 of r cubed plus, because notice this minus sign, I put everything here in brackets so it would distribute, minus, so this plus, sorry, the sum from r is equal to 1 to 19 of 3. So remember, we actually have a rule for r cubed. It is, I noticed in this way too, that we could actually use here, because we said that r is equal to 1, so we have no problem using the equations. So we know that the sum from r is equal to 1 to r cubed, sorry, from r is equal to 1 to n of r cubed is equal to n squared multiplied by n plus 1 all squared all over 4. Okay, so using this now, let's solve this question. So what this tells us, so we have 100 squared, because 100 is our n, multiplied by 100 plus 1 all squared all over 4 plus, remember this is a constant, so it'll be plus 100 times 3 using the summation laws we mentioned above, minus, I'm just going to erase this so I get some space, minus would be 19 squared, and divided by 19 plus 1 all squared, n plus 1 all squared, all over 4 plus, because again remember the minus sign distributing, okay, it'll be plus 19 times 3, okay, and when we do that we should get this value here, 2546640. Sorry, 2546640. Okay, I just kept it there because it was a long number. Okay, so again, this is the end of this questions tutorial. So this was a pretty short video. So this is basically all the questions going to come. Okay, so keep it simple. Another thing we could do too, so I'm gonna redo back over this question actually, and I'll show you another way how we could present it. So let's say we want to answer this question 2 in terms of n. So we want to find, so I'll add in another question 4. We're going to find the sum from r is equal to 1 to 50 of r squared plus r, right? This would be equal to, considering n is one term, it'll be, if you want to find r squared, it'll be n into n plus 1 multiplied by 2n plus 1 over 6 plus, so this is where we add an r squared, but no, this is not substituting the value of n as yet, because what I want to find for this one is just the sum in terms of n. So what I could actually do an application of this is that if I want to find it for varying values, let me say I want to find it for 100, if I constantly change the value of n, I could have a general equation which I could use. So again, so this is where we add an r squared here, plus n multiplied by n plus 1 all over 2. Now, these questions are fairly simple, okay? The hardest part in this now, what people don't understand and have trouble with, is the factorizing. So we have to look at what common between these two terms here and factorize it, because we're going to be want to get the answer in a simple form, okay? So what is common between here? We notice that we both of these have an n, and both of these have an n plus 1. So it's common, so we could factorize it out, okay? So what it'll be n multiplied by n plus 1, okay, over, so we want to pull out one of the denominators, but the question is now what we're pulling out, the 2 or the 6, okay? And this is where it also gets a little tricky, okay? So let's see, what we want to do is pull out the, well actually no, let's leave it like that. We'll leave it in there and then we'll see how we could simplify it after. So it'll be n multiplied by n plus 1. So if we factor out n multiplied by n plus 1, we'll get 2n plus 1 over 6. And we plus, what we have here is a half. Okay? Because we factored this out, so we just have 1 remaining there now. Okay? And then what we could also do is simplify this. So we get n multiplied by n plus 1. And how do we simplify inside here now? Okay? What could we do to simplify inside here? Well, the simplest thing we could think of to do, because normally this gets a little challenging, okay, is we could take the 2n plus 1 multiplied by 2 plus multiply the 1 by 6, and then all over here it will be 6 times 2. Okay, because these questions normally people have problems factorizing out the denominator when it's a constant, right? But so there's an easy way to do it. This is basic um adding, subtracting, and so on, right? So again we're keeping it slow. I try to keep it simple. N into n plus 1, and let's expand. Now this should supposed to simplify more, so it'll be 4n plus 2 plus 6 all over 6 times 2, which is 12. So this actually looks like if it would simplify, right? N into n plus 1 all over 4n plus 8. But we could actually factorize out 4. So it'd be 4 multiplied by n plus 2 all over 12. Okay? And notice this here simplifies. We get 3 here. So what this will be equal to, okay, is n multiplied by n plus 1 multiplied by n plus 2 all over 3. So rather than, we could actually simplify it. So again, we could get the same answer now if we take 50 and substitute it into here, into this equation here. We're supposed to get the same answer that we got above. So if the question asks you to get the answer in terms of n, this is how you do it. Again, this part here proves to be the trickiest part. Okay, so only the best easiest way to simplify, mu multiply here, and then multiply here to get the denominator. Okay, and that's normally the easiest way to go about doing it. Um, if you know the if you good with factorizing and you know how to do it on your own, you don't have to go through this step because the result still ends up simplifying. Okay, so that was it for this video on series and sequences questions. More videos will be published soon, and I hope all is well with everyone. Thank you.